Hey everyone, I figured it would be helpful for me to kind of put together a video really talking about R squared. So talking about what is it and why do we use it. And that's what we're going to be taking a look at in this video. So here I just have a sample image that shows a trend line. You'll see a number of words for this. You might call it a trend line. You might also see people refer to it as a best fit line. It really is a line that we think does the best job of representing some data here. So things to remember about this is that when we are looking at it, let me pick a different color here, like a red maybe. That sounds like it'd be pretty good. Like these, or green, I'm colorblind. These right here are what are usually referred to as the observed data. I mean, some people might say that this is the actual data. Typically, when we've been marking our things on our plots with Excel, we also get these points right here. But we shouldn't restrict it to this. All of these points, whether it is right there or even a point that is, somewhere on this line that isn't necessarily defined, these are usually referred to as the predicted data points. So this is where we expect the data to fall when we're talking about this. So when we talk about R squared, the idea, we might remember before we used R as kind of being variance. R squared is the statistical measure of how close the data are to the fitted line. All right, so really, when we talk about R squared, it's really pretty straightforward. It really is the percentage of the response data around its mean. So I suppose you could say it's the explained variation divided by the total variation. And so what we're talking about here with the variation is, we've talked about outliers and things. This line explains some of the variation that we have, why these data points have changed, but it doesn't explain all of them. We might say it explains 90% of the variation is explained by this line, like it follows this pattern, but there may be some things that fall outside that pattern. And that's what we're talking about. So when we talk about R squared, 0% really means that the model, the line, doesn't explain anything. So we'd say the model explains none of the variation. Whereas when we talk about an R squared has a value that is closer to 1 or 100%, that means the model, the line, explains all of the variation. Okay, so keep in mind that we usually talk about these things being the residual. So when we have something like we've calculated R, and R might be 0.93 as an example. That means that R squared is really going to be 0.93 squared. And you'll notice because I'm squaring a decimal like this, and I'll jump over to a calculator here real quick and just throw that in. So let's just go 0.93 squared equals. We're going to get a value of about 0.86, 0.865. We'll throw that in there. So jump back in here. So R squared is going to be 0.86 or 86%. What that means is 86% of the variation that is occurring is explained or predicted kind of by this model. And a couple of the things that we're going to find out, or at least people will assume, is that R squared People say, well, the closer it is to 100%, the better. And we'll talk about that a little bit. But here is some pictures that are going to maybe help us understand this a little bit better. If you take a look, I've got two sets of data. Both of them have a best fit or a trend line that is put in here. So as far as some of the numbers go for this, the regression model on the left here accounts for 38% of all variation. So 38%, that means r squared is 0.38. And if I go backwards, that means r is the square root of 0.38. And once again, square root of 0.38, whoops, not 0.68, ends up being about 61, so 0.61. So you can see that this would have had a correlation value of 0.61, but it has an r squared value of 38%. 38% of the variation is explained by this value. Whereas over here, I think you'll recognize right away that because these values fall a lot closer to the line, this is going to have a higher r value. All right, so the r squared value over here is about 87.4%, or 0.874. Again, finding r means finding the square root of 0.874, which, and I'll just do it here. Well, I don't have square root on that calculator. I'll do it back on this this right here. So square root of 0.874. Oh man, I can't type. Can't use a mouse actually. Is 93. So an r value of 93. So you should notice a few things about this. That again, this high r value, we said that tells us that the data is really close to that line. That line is a good model for that. Also means it has a high r squared value. All right, those kind of go together. Now, the one thing to remember is that r squared talks about how close the data fits a representation. Okay, so r squared cannot determine whether or not the predictions are biased, or whether or not it's a good plot or regression model, whether or not it's a good choice. We can have regression models that are not linear models. So here is an example. Here's a fitted line plot, and you'll notice that this model, you could say, I could go in here and say like, oh, here is the line that best fits this. All right. It won't tell me the difference. It won't tell me like, oh, this value really is a good fit for that line. So it doesn't tell you whether or not it's necessarily adequate. Like saying, oh, I have an r squared of 98.5 doesn't necessarily tell you, what type of line that we should be using, or if we should be using a curve or an exponential regression, things that we'll get to a little bit later. It's also doesn't, we usually think of like a high r squared value. So if I have r squared, let's say r squared is 98%, that doesn't necessarily mean, like in this case, that the straight line model is going to be a good fit. But in some fields, having r squareds that are like, oh, 38% or 39%, that doesn't necessarily mean it's bad. Fields like psychology, for example, humans are hard to predict. So there are some fields where r squared values that are under 50% are completely adequate. So an example of that, here not only do we have this fitted line plot, but we also talked about residual plots, where it shows us the fitted value versus the residual. We don't like to see patterns in this, and you can see kind of the pattern coming through here. That's kind of, it's all fitting that. We like these residual plots to be completely random. We want them to be random when we're going. We want some above and below. We don't want this pattern where when we're in between these values, it's always below the value. When we're over here, it's always above. That's not good. So we don't like that. That's one of the things we look at for that residual plot, or one of the reasons that we do it. So really in a nutshell, kind of breaking it down, A high r squared value tells us that it's going to fit a plot, or it's going to follow a pattern. It doesn't necessarily tell us which pattern it follows, or it doesn't necessarily mean that it's going to be the best pattern. Like this one has a high r squared value. The r value, we talked about it being the linear coefficient. It tells us like, yeah, I could make a straight line for this. Mine's maybe not in the best place here. Maybe it'd be over here, but that doesn't mean that it's necessarily the best type of pattern for this. And you can see, because when I put this straight line on here, notice it's to the left or above the line, it's below the line, it's above the line, it's below the line. That's what this is showing here. Above the line, below the line, above the line, below the line. I don't like that pattern. That kind of tells me that this would have been better by the one that they had, having this exponential regression. All right, so keep that in mind. The basic calculation, though, is in order to do r squared, we find that correlation. Remember, you can do that a number of ways with Excel, but we find the correlation r equals whatever, 0.95. R squared equals simply 0.95 squared, and that tells us the percent of data variation explained by the model that we choose. All right, so that is r squared. You'll see that sometimes when they talk about things like, they'll say like, oh, hey, 27% of the data is explained by something. That means, or variations explained. That means 27% equals r squared, or 0.27 equals r squared. So r, the correlation, is going to be the square root of 0.27. So really simple to do, but I think it can be confusing because we keep seeing r and r squared. So hopefully that helps explain what one of those means, and maybe helps clarify the other as well.